Hey guys, welcome to lesson 9 of unit 10. Just fix that over here, that's lesson 9. Okay, so don't get confused with that. Anyways, this is mostly a review lesson. It's just practice. It's not the review lesson. We have a separate review lesson, but this is more practice with probability rules. So I would highly recommend you trying the whole lesson on your own and then watching my video and checking back the answers. So the first question says a pair of dice is rolled. Again, when a pair of dice is rolled, your sample space is what? 36. N is equal to 36. Two possible events are rolling a number less than 5. So this is less than 5. And please circle your operators because I've seen in the past, even on the quizzes, people were making mistakes of not circling the and or operators and confusing themselves. So please circle that. And rolling a number that is odd. So are these two events mutually exclusive? So first of all, let's talk about the definition of mutually exclusive. Mutually exclusive means the two events cannot happen at the same time, right? So on one die, can you roll a number less than 5? Yes. And on the other die, could that number be odd? Yes, there are numbers that are less than 5 and odd that are 1 and 3. So so these events are not mutually exclusive. So no, not mutually exclusive. Exclusive. I can't spell. Not mutually exclusive because they can happen at the same time. And moreover, it's not asking me for the probabilities. If it was asking, then I needed to do it. It's just asking me explain it, okay? So don't do anything extra when you can lose points for it. So a pair of dice is rolled and the resulting number is odd. Which of the following events is the complement of this event? So this is your event happening. The number is odd. What's the complement? Complement means opposite or negating that. It means the number is even, right? Complement means not odd, which means even. So I'm going to write that down. Complement of odd is not odd, which means it's even. Okay. Nicole has a soccer game tomorrow. She plays goalie 60% of the time of the games. So probability of goalie, I like to write it as 60% can be written as 0.6. There is a 30% chance that it's going to rain. So probability of rain is going to be 30% can be rewritten as 0.3. How am I getting those numbers? Divide 30 by 100, which would be 0.3. 60 by 100, 0.6. If the probability that Nicole plays goalie given that it rains, so probability she plays goalie given it rains is what? 0.6. Could these two events, what can be concluded about these two events? So let's check. First of all, these are definitely not mutually exclusive because they both can happen at the same time, right? So that's our out. They're not complements. We're not saying what's the probability she's playing game and not game. So either it's dependent or independent. So when we are given, when we're given probability of A given B here, goalie given it rains, what's the rule? Again, we know all the three probabilities. It is probability of goalie given it rains is going to be probability of goalie. Are these two probabilities the same? So probability of goalie given it rains is what? 0.6. And probability of being a goalie is 0.6. Is same thing as 0.6? Yes, so these events are independent. Okay. Number 4. Blackberry Middle School has a population of 1450. So what does that mean? My N is 1450. My sample space is 1450. As I go along in the questions, you need to start writing it down. The number of students who prefer apple pie is 762. See, we're working with probability. If I said number of students, then that's right, 762. But if I asked you, what's the probability of students that like apple pie? So probability of apple pie would be what? 762 out of the total, which is 1450. Remember, your probability is a number between 0 and 1 or 0 and 100%. The number of students who prefer a cherry pie, so probability of a cherry pie would be what? 535 out of 1450. So it has to be out of 1450. If the probability that a student prefers either apple pie or cherry, it's OR, so OR has to do with union, is 985 over 1450. They want us to find what is the probability that students prefers both. Both has to do with and has to do with intersection, right? So that's what we're looking for. So we know this is going to be an addition rule because we're given OR. So probability of A or C is probability of A plus probability of C minus probability of A and C. I'm looking for this part. I already know the remaining. So this is 985 over 1450 equals 762 over 1450 plus 535 over 1450 minus, I can call this either X or I can just leave it as probability of A and C. So now I'm going to add this up and then I'm going to subtract it. So 762 plus 535 is 2 and 5 is 7, 6 and 3 is 9, 7 and 6 over 1450 minus X, 985 over 1450. I'm just zoom in here so I get more room. I'm going to subtract this. I'm going to subtract 1297 over 1450. I'm going to subtract 1297 over 1450. This cancels. What is negative 1297 plus 985? It is negative 312 over 1450 equals negative X. Divide by negative 1, the negatives cancel out and you're left with X equals 312 over 1450. You can choose to simplify it, which will simplify to 156 over 725, or you can keep it like that. If the answer asked me for percent, you could have just put it in the calculator and calculated the percent, right? We're all good with that, so I'm not gonna get into it. Number 5, the set of data in the table below shows the results of a survey on the number of times it should be on the number of times that people of different age groups work out each week. So it's giving us a table. Again, whenever you're given a two-way frequency table, you need to make sure that your totals are done, which are not done. So we're going to do the totals first, right? That's very important. And this number here will give you your sample space. So if I add up 6 plus 45 is 51 plus 84 is 135. Add up these. You can use your calculator if you don't want to use it, do it in your head. And that would be 54. This would be 48, 137, 128. And if I add up this number, this should be same as adding up these numbers. The sum of this or sum of this should be the same. If it did not match up, then you know you made a mistake, okay? So 313 is your total sample space. So now it's saying if a person from the survey is selected at random, what's the probability that it works out over 5 times a week given the person is in the ages of 19 to 25. So basically I'm looking for how many people are working over 5 times, and the keyword here is what? Given. So let's write this down. Probability of over 5 times. I'm going to write over 5 or greater than 5. I could have done that. Given they are in the age group of 19 to 25. So what's the probability of a given? It's the intersection over the given, right? So what's my intersection of? I'm going to actually circle it. Over 5, it's this. Over 5 is this, right? And 19 to 25. So what is the overlap? Where's the overlap happening? It's happening at 40. So this would be 40. That's your intersection over the given. What is the total of ages 19 to 25? It is 124. You can simplify it to 10 over 31, which is 0.3225 or 32.25%. But we can, this answer, as long as it's simplified form, is totally acceptable. What is the probability that a person selected at random works out 3 to times a week or is between the ages of 26 and 50? So this is an or question. So probability of 3 to 5 or age 26 and 50, right? So that would be, an or has to do with addition. So it will be probability of the first event plus the probability of the second event minus the probability of the intersection of the two events, right? So I'm going to actually erase this. So that way I know what I'm doing. So here, the probability of the working out 3 to 5 hours a week is what? 3 to 5 is 137 out of what? You just cannot write out of, it is probability, right? Out of 313, that's your sample space. Probability of 26 to 50 would be 54 over 313. And then you have minus the intersection. Let's do the intersection. You have 3 to 5. I'm just going to scroll it down. So this is the group for 3 to 5. And then you have 26 to 50, which is this group. Where is the overlap happening? At 20. So 20 is the overlap. So it's going to be 20 over 313. You can put that in the calculator, add the numerators. You don't do anything with the denominators. They're like denominators, so you didn't have to put the denominators in the calculator. Just put the numerators and you'll get 171 over 313, which is Part C. If a person between the ages of 13 and 16 is selected at random, what is the probability they work out 0 to 2 times a week? So here we are given a condition here. Isn't that a condition? So the condition is you're looking at all the group of 13 to 18. So your denominator is going to be what? 138, right? And you're looking at how many of them work for 0 to 2 times a week, which is 6. So it's going to be 6 out of, not 138, sorry, 135. 135, so 6 out of 135. If I was to write, you would write looking probability of 0 to 2 times given it's 13 to 18 age group, right? Which is the intersection over the given. Are the events between the ages 19 and 25 and works out over 5 times a week independent? So again, the definition of independent, we know two things, right? We have two rules to check that. We're going to use the probability of 19 to 25 and over 5 hours of workout is equal to, that's a question mark, so probability of event A times the probability of event B. So the probability of 19 to 25 and over 5, we can literally do the intersection. So here, let's erase this. So I am looking at 19 and 25. I'm going to actually highlight it. So this is 19 and 25. Right, this group is 19 and 25, and then I have over 5. I'm going to do a different color so you can see it. Where's my overlap happening? At 40, right? So that my numerator is going to be what? 40, oops. So that would be 40 out of my sample space, which is 313. What's the probability of 19 through 25? All of 19 through 25. How many are there? 124 out of 313. So 124 out of 313. And same thing, probability of over 5. How many people, total people work over 5 times a week? It is 128 out of 313. If you put that in the calculator, you get this 40. Okay, you cannot compare fractions, unlike, you know, your denominators were all same and you would have compared one fraction to one fraction. So the best thing to do is do decimals, put 40 over 313 in the calculator, and don't just round it to 1 or 2 decimal. At least write 3 to 4 digits. So it's 1277, and here you get 0.16201. These two numbers are not equal, therefore must write a statement, not independent. Okay, number 6. I actually want you to do number 6. You can try number 6 on your own. I will do number 7 with you. The registrar's office at Joyful College has reported that that of the incoming freshman class, 24%, which is 0.24, are math. So probability of math is 0.24. Probability of computer science, 14% is computer science, so that would be 0.14. And then it's saying 7% are in both programs. Both has to do with your operator and, so probability of math and computer science is 0.07. Okay, when in doubt with your percents being converted to decimals, guys, please divide it by 100. Okay, don't make those silly mistakes. So probability of M given C, again, M given C. Always write out, it's the intersection of the two events, so it would be probability of M and C over the probability of the given. C is your given, so probability of computer science. So what's M and C? It's 0.07 over probability of C, which is 0.14, which is 0.5 or 50%. So what does this mean in the context of the question? That's what my second statement is saying. Central registration must report this information to the state. Write a statement relating your calculated probabilities to student enrollment in the given situation. So what does that mean, right? We looked at what? We looked at the population of computer science, and we found out how many are taking math. So I can say 50% or 0.5 of all students enrolled in computer science are taking math. Okay, so I want to do one last question, number 10. So number 10 is asking me, on the camping trek, Marie kept a log of the types of snakes she saw. She noted their colors and approximate lengths. So anytime you're given a frequency table, you want to make sure that you do the totals. So let's first do the totals, then since they're not done. So 3 plus 5 is 8, 4 and 5 is 9, 3 and 4 is 7, and 5 and 5 is 10, right? I don't want that line there. Oops. So what is 10 and 7 and 10 is 17, or whether you do 8 or 9, you do end up get 17. 7 or 10, it's 17. So your sample space is, or your n is 17. Okay, so here in this question, this is a little tricky question. Using this data, determine whether a snake selected at random that is 2 feet long is more likely in the area if the snake is red, or if the snake is bright orange. So this is a given condition, but we have to check for 2. So it's saying, again, it says justify. When it says justify, you must show your work, right? So probability of a red snake given, it's 2 feet long. That, and we have to find a probability of an orange snake given it's 2 feet long. So I have to find the percentage or the decimal for both of them, and then compare which is more likely to happen. So again, what is probability of R given 2, or red snake given it's 2 feet long? It's the intersection of the two events, so it will be probability of R and 2 over the given, right? So how do I find the intersection? I'm just going to look for the overlap. So the probability of red is this row, and the probability of 2 is this. Where is the overlap happening? It is happening at 4, right? So it will be, my numerator is going to be 4 over, what's the probability of 2? Probability of 2 snakes is 9. So this is 4 over 9, which is 0.44, or I can say 44%. The next one, orange given it's 2 feet long. So again, it's the intersection of the two events over probability of the given. So let's highlight the probability of orange, bright orange, which is this row, and 2 feet long, it is this row. Where's the overlap happening? At 5. So the numerator would be 5 and the denominator of course is going to be 9, which is same thing as 0.55 or 55%. Yes, so which one is more likely? Which one is a higher percentage? 55. So 55%. So it in the area, it is the probability of seeing a bright orange snake. So the probability, or it's more likely, I'm going to use the exact word, it is more likely to see a bright orange snake given it's 2 feet long. Right? So finish up the remaining questions. I think you're left with just 4 questions to work with. Make sure you do the closure also. And do not forget the totals to do on your frequency tables. And if you have any questions, please reach out to your teachers. Good luck, guys.